Hello everyone and welcome to today's event, and you join us on a chilly day here in the UK from wherever you're joining us, and I'm your host today. My name is Nigel Ward, and I'm going to be guiding you through the event today and introduce our speaker in just a moment. So wherever you're joining us from today, just to give you some perspective on where we are, yesterday was the day that the Chinese space station astronauts landed on the moon to gather some moon samples. Here we are in Earth, and coming to you today from the southern part of England, from Surrey. Those of you that are local, very warm welcome. And also to those that are joining us from much further afield, and in fact people joining us right the way around the globe today. So I hope you enjoy that. And this is a Christmas event, and somewhat fitting for a Christmas event, we're talking about flight and levitation. So if we think that some of the things synonymous with Christmas are Santa Claus and elves, so let's get a little bit in the Christmas spirit today with a Christmas hat, and oh, we've got to have some Christmas lights as well. There we are. So I think we're just about ready to go. This, in fact, for the IET Surrey is our 18th annual Christmas lecture, the 18th that we have staged, first being in 2002. And I can't think of anything better to talk about today in the Christmas theme than levitation. So our speaker today is Abhishek Gotem, and he's going to be on the stage in a moment. Now, Abhishek is a PhD researcher in aerospace engineering from the University of Bristol, and he's worked on the cutting edge fast-paced technology environment of Formula One with Red Bull and BWT Racing, and also with aerospace giants like Rolls-Royce on their aero engines. So I think you're about to see the connection between aero engines and what Abhishek's going to be talking about today. And he's the lead research project collaborator between Bristol University and Gravity Industries, and together they're pioneering the innovation which is reimagining human flight, and that's our topic today. So without further ado, I would like to welcome Abhishek. Now, during the talk, I'm sure you'll have lots of questions and things that that you can think of. I've certainly got a few questions of my own, but I hope you'll come up with some as well. If you would be kind enough to submit your questions using the Zoom Q&A facility, if you're using a browser or the Zoom app, it's down on the bottom of the screen. If you highlight the Zoom bar, you'll see the Q&A button. If you wouldn't mind asking your questions through that. And on hand, we have Richard, Samantha and Michael, who will be taking your questions and giving Abhishek a good grilling somewhere towards the latter part of the talk. So are you ready to go, Abhishek?
Yep, I am. Thank you. Is it
going to be a good one?
Yeah, I hope so. I mean, there's all this stuff that we can talk about here. So yeah, looking forward to this talk. Thank you for introducing me. I want to quickly share my screen.
And over to you.
I want to quickly share my screen so that everyone sees that. Right. Hoping everyone can see the screen. So hi everyone whoever's joined us. My name is Abhishek, and I'm a third-year aerospace PhD student at the University of Bristol. Currently looking at sort of noise reduction technologies for civil aviation aircrafts, and I also work as the university technical project lead for Gravity Industries. So I'm here to sort of talk about Gravity Industries and the opportunities that I've sort of gained working with a fast-paced startup like Gravity. First of all, I'd like to say flight sort of a subject that's inspired generations. It certainly inspired me from a very young age, which is why I took up aerospace engineering as a degree in the first place. And a lot of it was down to the fact that sort of I lived next to an airport and watched aircraft fly over my house on a daily basis, and was just mesmerized by the fact that such a huge structure with so many people on board could just magically float in the sky. And humans sort of have become very good at designing aircrafts and helicopters. However, Gravity's story started out with our CEO, Richard Browning, wanting to ask the question, what if you could reimagine the whole approach to flight, and instead of using a vehicle to help you fly, use the power of your human mind, which is sort of one of the best computers out there on the planet, and use that as the control center for your balance, and use your body to be the mechanism to support yourself, and sort of combine those two together with just the right amount of tech to make you fly. As sort of both human mind and body sort of can achieve almost unattainable feats if you focus them on a singular challenge. Just to give you sort of a reference, I mean, if you look at sort of people like Felix Baumgartner, who sort of skydived from the edge of space, breaking the sound barrier in the process, or a Formula One driver pulling 6 Gs when they're going through corners, the human potential is just endless if you put your mind to something. So for the sheer sort of joy of the challenge, we at Gravity set out on a journey to find out how far we can stretch this whole mindset. So now we weren't crazy enough to sort of think we can flap our hands and generate sort of enough lift to fly. So we need some kind of device to give us enough thrust to lift us off of the ground. So in 2016, we started playing with sort of one of these that you see on your screen. It's a small little micro gas turbine engine. And most of you must be familiar with the gas turbine engine. It's sort of the heart that lies within any aircraft and helps propel any aircraft into the sky. So we were working with a smaller version of that, and the basic principle of the gas turbine is pretty much ingesting air at a lower velocity on the inlet and throwing it out at a higher velocity, thereby sort of producing thrust. So the engines we started testing with that you see on your screen, they were putting out sort of 22 kilos of thrust each engine. And you can see us sort of trialing out just one engine on an arm on an aluminum tube mounting in a country lane with sort of a mop bucket. That red bucket is a mop bucket, which was our makeshift fuel tank. And this initial run actually taught us a whole lot of things. Namely that the assumptions around sort of ripping, assumptions around a jet engine on your arm, ripping your arm off, or generally just setting everything to fire was not true. And it was really just a good example of not entirely believing on sort of conventional wisdom, and in as safe a way as possible, try out things that you want to sort of try out. So we were using a fuel container in a mop bucket and wanted to check if there's any oncoming traffic and just test this engine out. But it was quite profound. It just felt like sort of a big fire hose on your arm. Moving on from here, I mean, there's obviously one thing that you can do, having done that, is have 2 engines on each arm. So this video, you can probably see, you can have some idea of the power when Richard tries to sort of push the engines out to the side. When you're actually leaning on them, it's okay, but now you know there's over 100 pounds of thrust that you're pushing on each arm, and it's quite hard to stand upright. So you can see I'm sort of trying to hold them all together. So in the theme of what you're going to see next, we went from 2 engines on each arm to 4 engines on each arm. And that's sort of the progression we were following to see how we can sort of control the power of the jet engine. So with 4 engines on each arm, we were then sporting quite a bit of power. That's 44 kilos of thrust on each arm. And it was really quite manageable with even 2 engines on each arm. And you can really feel that moon gravity hops and jumps when you were powering those engines to full throttle. That's quite a funny picture, just showing what we tried in the spirit of exploration, carried out flying over 2016, many different kinds of arrangements of these engines. So we mounted them on our arm, on our legs, and technically speaking, like apart from this particular concept, we were trying engines on our leg with a tether attached to our back to see how that feels. Technically speaking, apart from it being sort of very difficult to balance your arms and legs in all one go, you had now a tether on your back which was pulling you in all sort of directions. So it was really difficult to comprehend that. So we sort of went away from the tether concept, and Richard just got used to sort of falling over and failing in that manner to learn how to control the whole suit. That's another concept we tried. It was a silly idea that we did. That was 3 engines on each arm. It's way too many engines, 66 kilos of thrust on each shoulder, which was way too much, way too unstable to handle. So we quickly sort of developed away from it. Then there was sort of another model here where Richard's doing the similar thing, what he was doing with the tether, with 2 engines on each arm and an engine on each leg, but without the tether this time. So he was trying to learn the balance and control without having a tether to support him. What we realized, the funny thing that we realized is that if something's sort of pushing on your feet and yet your feet are not touching the ground, so if something's pushing you up, the human mind has sort of this tendency to like bend its knee, which is not ideal when you're trying to mount a jet engine on your leg and trying to fly. However, the model of having 2 engines on each arm and 1 on each leg ludicrously was sort of starting to work together, and it was just a question of us trying to learn how to control it and make steady progress from there. So we tried developing this configuration further and further, and about November 2016, after all the evenings and the weekends and crazy times spent working at a wet farm in Wiltshire, Richard managed to do this, which was sort of our first pivotal moment when the idea actually turned into something that's feasible and actually works. And that was the first ever sustained 6-second flight of a gravity jet suit. And from there onwards, the rest was just history. So cut that long story short, Richard launched this company, Gravity, in 2017, about April 2017. And this is a little clip of what the suit is capable of doing now. We've flown in over 100, we've flown more than 100 flights in over 30 countries. And let me just on this, I think it stopped playing the video. We've done over 100 flights in over 30 countries because usually a jet suit, who knew, sort of fits in 2 check-in suitcases, and you can just take it in your sort of normal check-in luggage in an aircraft. So you can go anywhere in the world with a jet suit. All you need is someone who's just kind enough to find you some diesel or jet fuel, and then show up and do something like this that you just see on your screen. Now, interestingly, the civil aviation rules in nearly every country we've been in fact, every country that we've been in, otherwise we'd probably be in prison, turns out they don't cover jet suits at all. So it's really quite lucky to discover that, because we then have the freedom to fly in pretty much any country because they're not covered in any country's aviation rules. This particular act that you see on your screen, Richard did that with the Royal Navy, in collaboration with the Royal Navy, as a demonstration of the ridiculous degree of control and stability that the jet suit can offer you now. And we've got about 7 pilots in our team now, and we reckon probably half of them, with only a cumulative of 2 hours of flight time, could have the same level of stability and control and fly the same way as Richard can in this video. And Richard can't really ski or skateboard or do anything crazy, and what he usually says is he can do this while reading a bedtime story to his kids, and that's how intuitive it is to fly the jet suit. Similar to riding a bike is what usually all the jet suit pilots say, and it's all a credit to the way the human brain can just sort of adapt to a roughly similar balance regime that you experience every day when you're walking around, basically. The boat that was moving in this video, it was actually trying to lose Richard, but Richard didn't even notice that was happening. So yeah, it just shows how crazy it is and how far we've come since 2017, since that 6-second sustained flight, just not less than a feet off the ground, basically. There's an example of sort of kind of the crazy places we've been in, and also sort of accidentally raised over $500,000 in a car park. That's something we don't have time to cover, a story for later on. But at Gravity, we're actually sort of proud that it's a money-making business. So we actually put all the money back into R&D, and it's not like we're just burning through some crazy sort of VC funding or anything. We make most of our money through sort of events that we do, and we also do flight training for loads of our enthusiastic clients. Sort of our first female pilot, you can see on the top right, after just one day on the tether on our training system, she was able to hover. So it's just great, as you can just genuinely sort of relax and try to sort of learn how to control this massive 1,000 horsepower beast, and you can be relaxed that you're not going to fall over, and you eventually know that we're going to give you enough power that you can like reach the roof of our training center, but we'll only give it to you when you demonstrate enough skill to do that. We actually also sell the suits. We've sold sort of a couple of suits for about nearly $500,000 each, but we don't really like selling our suits because we don't really know what people might end up doing silly things with these suits, and that might not be good in the end. In terms of how my story started with Gravity, as I said, I'm a PhD student at the University of Bristol, and back in 2017 when Gravity launched and I was starting my PhD, I was really fascinated by the launch video that they posted on YouTube, which was done by Red Bull, I think, and I just reached out to them, just sent in a speculative email on their website email address with my CV attached to it, and surprisingly Richard got back to me within 2 days and invited me to his house to have a chat about how I can help Gravity and help them move forward with their technical development. So that's where sort of the whole story started, and the initial idea was to have a collaboration between the University of Bristol and Gravity Industries to enable bachelor's and master's students to carry out their final year research projects with Gravity and get some work experience and the ability to work on a cool and fun project whilst helping Gravity push their technical side of things. So that collaboration was sort of fine-tuned and ironed out in 2017, and it's been going on since. We've had over 20 or 30 students go through the whole program and finish their final year projects with Gravity. The benefits that Gravity has given to sort of our students is sort of helping students work on real-world projects where they can physically see the impacts of their project in real life, which usually as a student in a university, you don't really get to see that. You get to work on projects, but never get to see them being implemented in real life. It gives them the opportunity to sort of experience a fast-paced environment, sort of a rapidly growing technology startup, which is sort of gives you the key skills and expertise that you would probably need once you graduate and go on and look for a job. And obviously, it's a great experience to include in your CV because you can have loads to talk about when you go out there and search for jobs, basically. But the biggest thing that working in fast-paced startups, and especially Gravity, gives you the opportunity to sort of network with influential people and high net worth individuals, and also the opportunity to go on and work for Gravity after graduation, which you can see the two images that I've put on this slideshow. The top left image is Sam Rogers. He's one of our engineers and also a Jetman pilot, and he was just a regular university student at the University of Loughborough, and he joined Gravity as well in 2017, and since then he's been designing both the jet suit and also been flying them in multiple countries and on multiple events. Same with Alex Wilson, who was actually my junior at the University of Bristol. He was a master's student, and he sort of approached me to just get some work experience of Gravity, and joined Gravity in 2018, and has since been one of the lead electrical engineers there, and also been a jet suit pilot and sort of flown in multiple countries as well, and spoken to many high network individuals and flown in front of them. And that picture of him on the bottom right is actually showcasing the suit to a Ministry of Defense individual. So it basically shows you the benefits that a startup can give to sort of students, like school students or university students who want to sort of work with us. Just to give you an idea of like what kind of projects we run. This was one of the projects we ran last year. It was sort of the aim of this project was to suggest sort of wing design changes to increase the range of the current Gravity industry suit. So one of the things that we've been trying at Gravity is to push for this vertical to horizontal flight transition, and also sort of push the range of the suit, and also reduce fuel consumption. And one of the only ways that we can do that is through wings. So we had a project running on sort of wing design and looking at options that can help us achieve that. Most of our students, they love working with Gravity because they find it as a fun project, and also something that they see as the future of mobility probably in the coming years. It's not only enjoyable for students, but also for technicians working in the university. They find it very rewarding because they get to work on projects which they usually don't get to work on in their day-to-day lives. So it's quite a nice, rewarding act for them as well. So sort of to give you a bit more sort of insight into what a university student can do with us, or even a school student to some extent can do with us, and they've done it with us in the past, is stuff like we worked on researching loads of different wing technologies and analogous technologies, and looked at our competitors to find their strengths and weaknesses. Obviously, we've got Gravity is not the only one doing jet suits and flying suits. We've got a few competitors all across the world, and we've got to stay on top of what their sort of strengths and weaknesses are. And our students and university students have sort of helped us research those ideas and push that forward. We've done loads of aerodynamic analysis and stability analysis on scale models of the jet suit, and that's towards working to build sort of a computer simulation of the model, where the whole jet suit can be modeled on the computer, and you can try out different wing configurations, different engine configurations, and simulate them without spending too much money in real life. We've done sort of aerodynamic performance improvements by changing the wing design, and that's helped us with reducing fuel consumption and increasing sort of flight endurance. And we've done loads of comparison of small scale models in wind tunnels with sort of full-size jet suit results from the real world, and that sort of really helped us with the wind tunnel to real life correlation. Which is something that's really needed to test loads of concepts in a fast and efficient way, and in the cheapest way possible to push the development process, basically. So one of our students, you can see on the top image here, is me and one of our students who worked on 3D printing sort of a scale model of Richard with a wing fixed to his back, and that scale model was then used in a wind tunnel to sort of collect aerodynamic data over a week using one of our wind tunnels, one of our large wind tunnels in the University of Bristol. And he also worked on sort of doing literature review of what wing designs are there in the market with our competitors or similar technologies, and he modeled them and manufactured them as well. And he also worked on safely sort of testing actual jet suit pilots from Gravity in one of our wind tunnels. So what you can see here is through sort of all these projects that we run with Gravity, students can get the chance of improving their design skills and manufacturing skills. They can sort of get hands-on experience of using a wind tunnel, let's say, which is necessary when you go out and find jobs in the industry. It's probably a priceless experience to have It helps improve your research skills and helps you find sort of relevant literature and helps improve your skills in terms of becoming a better researcher. And moreover, the hands-on testing, which is priceless, that you get as an undergrad, is sort of unparalleled, because most of the undergrad students at university only get to do computer simulations or just normal theoretical stuff, but hands-on experience is really priceless, which you can get basically. So you can start to see how this program has helped undergrads build up their personality and also be more ready for the industry with the hands-on skills and expertise that's needed that they gain through all these projects. As far as my story is concerned, Gravity has not just helped me to be sort of be a better engineer and be a better professional. It's helped me in loads of other aspects of my life. Working with Gravity sort of has been key in helping me sort of achieve various different things that I've been involved in. So I've been able to network and make friends with some of the leading influencers on the planet. So on the left-hand side of this slideshow, you can see I got to sort of spend some time and work with the Hacksmith, who's a very big YouTuber and who came in to do a collaboration with Gravity back in 2019. And he works on bringing science fiction objects to life through engineering. So I got a chance to work with him and collaborate with him and gain some skills from him as well. In the middle, you can see one of the biggest Bollywood superstars. His name is Akshay Kumar. He's the fourth highest paid actor on the planet, and behind the likes of sort of Dwayne Johnson and Robert Downey Jr. So I got an opportunity to work with him and his team to bring him to Salisbury for a jet suit flight experience and for flight training for one of his movies, which was such an amazing thing to do for me. And all this sort of network and experience to sort of enable me to set up my own marketing company in India. We call it HarborX, with one of our very first clients being sort of Amazon Prime Video. And you can see on the picture on the right, we've done an amazing movie promotion campaign for them recently, where we sent a poster of sort of over 15,000 fan signatures to the edge of space. So as a closing remark, I'd like to say that sort of Gravity's philosophy of always being curious and setting and focusing your mind onto a challenge has proven to be sort of the key factor in everyone's success at Gravity. And I would like to sort of take this opportunity to urge everyone who's sort of watching this webinar to sort of dream the impossible and just put your mind to it and make your dreams come to life, basically. And that's what I've learned, and that's what most of the people who work at Gravity have sort of learned through their whole experience. And if you've got any questions about sort of Gravity or myself and sort of my journey about Gravity, feel free to reach out to me over LinkedIn or anything. And I'm sort of happy to take any more questions that come out of this webinar. So thank you for listening.
Thank you very much, Abhishek. That was great. And funny enough, it's getting a little bit snowy in here.
That's quite nice. That's
Christmas
my
theme.
effect.
I think one of the important things that you highlighted there is that the work you've done on this project opened lots of doors for you in places. And
yeah.
And how long has Gravity been going now? How many years?
So it's been going for 3 years now.
3
It
years.
started in April 2017, and it's just massively multiplied its growth. And yeah, started off as just one single pilot flying just less than a feet above the ground to multiple pilots who can do tricks and fly over multiple locations all across the planet. So the main aim of sort of Gravity is we're working towards this international race series concept, where we'll have loads of sort of pilots from different backgrounds, different athletes from different backgrounds, flying at overwater locations, at iconic locations across the world. So think about LA, Dubai, Singapore, Bermuda, all those kinds of places, and doing making a racing series out of it. And that's where we're sort of ultimately headed towards. So yeah.
Oh, that sounds really good, and something that will definitely definitely captured more people's imagination.
Yeah.
In a way, that's also what the IET is about. We're approaching actually the 150th anniversary of the IET.
Awesome.
Started back, believe it or not, in Victorian days. It seems like hard to imagine that engineering started its journey of importance way back then. So, you know, today I think people still don't appreciate and understand all the things that engineering around them is responsible for. We wouldn't be here on Zoom today without it, of course, or many of the other things that we touch and take for granted today. So I think it's important that the way you've described imagining something and then bringing it to life, I think is one of the central things that engineering can do for people as they move through their careers.
Yep, that's totally true.
I think we've got lots of questions for you.
That's awesome.
I'm going to bring in the question elves now. They are Michael, Richard, and Samantha. And I think Michael has got the first question.
Actually, Nigel, it's me, Samantha.
Oh.
I've got the first question.
Okay. There we go.
So there's quite a few questions on the target flight times. I'm going to ask one from Shivan Patel, which is, what target flight times are you aiming to achieve within a year?
So at the moment, currently we're developing the wings. So without the wings, we can carry up to sort of 5 to 10 minutes worth of fuel to power us for 5 to 10 minutes of flight. But with wings, we sort of plan to push that up to 15 to 20 minutes probably. That's what we're targeting. It's not a hard target, but that's what we plan to do. 10, 15 to 20 minutes of flight, vertical to horizontal transition, and then flying for 20 minutes at speeds similar to a normal aircraft, I would say. So yeah.
With that in mind, are you aiming for distance or height?
Yes.
Or what's 20 minutes?
Distance. Well, there's two things. So distance is obviously a really big factor because, as you must have seen some of the recent videos that Gravity's released, we've been working with the air ambulance team to help out with some search and rescue operations and some emergency sort of operations as well. So distance is a big factor for us. So we're working on maximizing the distance and the flight endurance, but also altitude, because at the moment we are working on a parachute system to sort of save us from this thing called the dead zone. So between 0 and 50 feet, if we have an engine failure, we have no sort of way to sort of recover from that, because a parachute can't open fast enough to sort of save you from that. So with the wings, definitely we plan to both push the altitude and the distance, because the altitude is needed for you to deploy a parachute in case of a failure.
Abhishek, can I just ask a follow-on question? Does it depend on the type of fuel? Do you get different performance depending on whether you go with diesel or jet fuel in terms of the altitude that you can and the flying time, etc.?
We haven't really, we haven't really done any testing on that, but I would imagine it shouldn't really matter that much. Obviously, jet fuel is much better for the engines because it's designed to run on jet fuel, but both diesel and jet fuel pretty much provide us with the same sort of thrust levels, I would say, so it doesn't really matter, I would say.
Thank you.
Yeah.
Michael, are you next?
Yeah. So we had a few questions asking if the engines that you use are, standard ones that you can buy, or do you have to modify them? And also, you sort of touched on it then. If one of those engines fails, do you come down very quickly, or can you survive with the other three?
So to answer your first question, the engines that I first showed in the first few slides, those were sort of off-the-shelf engines. So we work with an engine manufacturer called JetCat, and they manufacture engines for these hobby aircrafts. They manufacture micro gas turbines for hobby aircrafts. So they used to be, the initial engines were sort of bought off the shelf, but since then we've worked with JetCat to sort of improve the engine and sort of make it a bit more tailor-made for gravity. So that's what we've done with the engines. In terms of a failure, we have had a few failures, nothing too serious of engines, and most of them were over water, and that's why we fly over water, is because if there's a failure, we just fall in the water, and then we've got a safety jacket, inflatable safety jacket that inflates as soon as you impact the water. So yes, you do lose. One of the key things that you have with engines mounted to your hands and in your back is that if any of the engines fail, you sort of get a torque that sort of twists you around. So yes, you do lose sort of a bit of stability when you lose an engine, but that's something we aim to fix with the wings as well, because when you're using a wing, you then don't use full thrust from the engines, in which case you have a bit more stability from the wings itself. So in case of an engine failure, you won't just spiral out of the sky and fall down, basically. So yeah.
Great, thank you.
Great. We've got a next question here is from Brian, and he's thinking about the military applications for covert insertion. Although I think this also applies to the use of the suits for sort of humanitarian use as well. But it's how much noise do the suits make?
So in terms of noise, I mean, obviously it's a gas turbine engine, so it makes noise similar to any aircraft. So it'll be about 150, 120 decibels, which is similar to any aircraft, which is quite a lot of noise, obviously, and that's what we've been working on as well. So my PhD is in aircraft noise reduction, so that's what my specialization is in, and I've been helping Gravity with some of the noise reduction aspects of it as well. We're also working on an electric version of the suit, which is already in development, and we already have a version that can work for actually people with who don't weigh as much, because we don't have the capability of pushing too much thrust from that. So the electric version of the suit actually doesn't produce as much noise as the gas turbine. So yeah, we're working towards sort of making it more and more sort of noise compliant, I would say. So, yeah.
So when you're working on your research, is it theoretical, or do you make lots of prototypes and try things? What's the way that you go about it? So
my research, although it's for reducing noise for civil aircraft, it's purely sort of experimental. So most of my research has been around making prototypes of noise reducing devices, and then testing them out in our wind tunnel at the university. So yeah, that's what I've been doing for the past sort of 3 years.
It must take a long time to make a prototype, and then
so
feeling of satisfaction when it works, and deflation if it doesn't quite do what you expect.
Yeah, so it's a lot of it is I would say in PhD. I mean, obviously you take loads of reference from already existing research, but a lot of it is also like sort of your own creativity and sort of trial and error as well to some extent. But 3D printing technologies have sort of really helped me, and even Gravity, with to push development as fast as we can. Because if I was waiting for sort of one of my parts to be machined or something, it would take ages for me to test anything. But at the current moment, both Gravity with their technical development and me with my PhD, we just use our 3D printers, which can print something within a few hours, and then we're good to go and test it, and then go on to the next option, basically, and just keep iterating through loads of options. So, yeah.
Okay, Abhishek, I've got a question here from Jim. So your video showed that some of your initial versions, you had engines on the legs, but it appears that they've now been replaced by 1 or 2 back-mounted engines. Can you describe this evolution? How did you get from?
So yes, we actually, the first from our first ever sustained flight that I showed you the video of, that was with 2 engines on each arm and 1 engine on each of the legs. So that was 6 engines in total. That's something we sort of developed away from. The main reason being, we found this funny thing that if the engines are mounted on your leg and you're trying to the engines are trying to push the leg sort of vertically upwards, your brain has this tendency to sort of bend your knees so it doesn't lock your leg. That's sort of something we found out, like something you can never sort of imagine. It's something we found out through sort of trialing and testing. And the problem is if your brain is trying to bend your knee, that's not really a good thing to do when you're trying to fly, because it's just going to give you a moment and it's going to sort of make you fall over. So we then moved on from that, and instead of mounting them on the legs, we moved them to just the base of the back. 2 small microgas turbines on the base of the back. That was the second version of the suit, and from there on, we have now developed into 2 engines on each arm. And a larger big engine on the back, because that's just for efficiency purposes, to increase fuel efficiency basically. So yeah, that's what's been working for us the best since the past 2 years.
Brilliant. Thank you.
Yeah.
We've got one here from Phil, who's asking if you mentioned that it's all done through the pilot's own brain. But is there any automation in there, any control software that helps with this?
So Richard's philosophy with Gravity has been using the power of the human mind and the body, and just augmenting that with just the right amount of tech to make you fly. So we don't use, even though we can look into, and loads of our competitors do have sort of thrust vectored nozzles and like complex ECUs and clever sort of systems that sort of control where your thrust goes and where your thrust points. We at Gravity don't sort of, we're not going down that route. We're sort of using the power of the mind and the body to sort of make you fly. So yeah, there's no sort of complex tech in it, apart from the fact that you're using your mind to sort of make you fly, and the power of some jet engines basically. So yeah.
Thank you.
Yeah.
Okay, thank you. We've got a couple of questions here on the regulatory side. You said at the moment CAA aren't interested in flying suits, presumably because they've only recently arrived.
Yes.
Do you expect the CAA and other authorities to start getting an interest, and if so, where do you think that might go?
So they've already shown an interest in us. So they've already like visited our barn, and like they've had a go at the suit and stuff as well. The main reason that they don't see us as a threat is basically we don't classify as an aircraft because we're below 150 kilos for now, and also the fact that we don't at the moment choose to fly more than 10 or 20 feet above ground basically. So they don't see us sort of as a threat, as they saw drones, because drones can fly at the altitude that they can sort of hamper an aircraft. We don't do that, so they don't really see us as a threat at the moment. So yeah.
Did the inspector have a go with the suit?
Yes, they did. He really loved it as well. So yeah,
that probably helped.
Yeah, it probably helped our case as well. So yeah, doing good now. So yeah.
Okay, Abhishek, we have a good question here from Jeff. He's asking, it presumably requires significant upper body strength to maintain control of the suit. How do you assess whether someone's going to be a good candidate as a pilot? I mean, what particular skills do they need, or what upper body strength or any strength do they need?
So in terms of, we get asked this question a lot. In terms of upper body strength, it's actually quite easy to fly the suit. It's not, you don't really need too much strength to fly it. It's pretty much the first few, once you get used to it, you get the hang of it. It's pretty much like riding a bicycle. You don't really need too much upper body strength to fly. As we said, we've trained a whole host of sort of enthusiastic clients who have different age ranges, from like young people to sort of middle-aged people, and all kinds of people, to sort of help them be able to fly. And loads of them have been able to fly without any sort of prior experience in being like strength training or any kind of crazy experience before. So it doesn't really need too much sort of upper body strength from a flying point of view. However, to be a pilot for our race series, we do look at people with sort of athletic backgrounds who have been doing stuff like gymnastics or parkour and stuff like that, where they already have a sense, where mind already has a sense of balance and control, because they have to sort of, gymnasts and parkour athletes have to like sort of use balance a lot in their day-to-day life. So we do look at people who have that experience already prior to sort of joining us. But in terms of being a jet suit pilot or coming to experience one of our suits, you don't need any sort of skill to sort of do it.
So if you contrasted that with your experience in Formula One, it's a lot harder to be in Formula One than in a jet suit.
Yeah, I would say so. Yes. I mean, in a Formula One car. I mean, I've worked in Formula One before, and I sort of race cars myself. I would say, yeah, jet suits, once you get the hang of it, is much easier, and probably maybe sometimes more fun. Like, I haven't been able to fly yet, but I'm pretty sure once I get the hang of it, it can be more fun than racing. So yeah, yeah.
I've got a question here concerning commercialization of the suit. Sort of what applications do you have in mind? And the follow-on question, bearing in mind that Christmas is around the corner, is when do you think they'll be available to be bought by hobbyists?
So in terms of commercialization, we actually do sell the suits. We had them on display at Selfridges in London until 2018, I think, and we had a few buyers who actually bought the suit for a hefty price, $500,000 each. But the main aim of Gravity is we don't really plan to sell the suits, because we don't really know what people would end up doing with them, and they might sort of end up hurting themselves, and it's just sort of a it can create like loads of problems for us and them as well. So we sort of focus on, if people want to experience the suit, they can book a flight experience with us and come and experience the suit, and then if they're good, they can try and learn be a jet suit pilot with us, where we sort of hold the jet suit with us. But we're not really keen on selling the suits as such. However, we do sell them if we do find a really keen, interesting buyer for it.
And if you have £500,000.
And if you have £500,000, yes.
Yeah.
Both those conditions. But yeah.
I think you're next, Michael, aren't you?
Right, mute. So one question that's just come in is about weather conditions. Is the suit powerful enough to deal with, flying in all conditions, or because you talked about search and rescue in particularly in high wind conditions, is that something that you would be able to deal with?
Yes, for sure. I mean, in terms of once we get the wings, that might be sort of a different challenge that we have to look into. Since we don't have wings, we just have a human body. Weather conditions isn't really too much of an issue for us, because the suit technically can fly in any weather condition. There's just a macrogas turbine engine, similar to any aircraft. It can fly in rain or wind or snow or anything. If there's really high winds, then that might be sort of something where we choose not to fly. However, it doesn't mean that we can't fly. So that's just from a pilot safety point of view that we don't choose to fly. But in terms of from a technical and a theoretical point of view, we can pretty much fly in any weather condition, I would say.
Presumably, if you were wearing goggles and you
Yes,
you couldn't see them, that would be a problem. Or
yes, I mean we do have on our helmet, we are also working sort of on a heads-up display system. So we do have different kinds of vision on our heads-up display system as well. So it obviously, with high rain or high poor visibility, it makes it difficult to see what's in front of you. So yeah, that would add to the challenge, but theoretically we can fly through really tough weather as well. So yeah.
And how about if you get the sudden urge to scratch your nose? What do you do?
Well, you land and scratch it, or you have to like bear with it. Yeah, you only have two options for now, at least. So yeah, that's what I would say.
Okay, I think the last question from me, Abhishek. Question asked by Alex Wood. You mentioned about competitors. How many competitors do you have, and how do their products compare?
It's a really good question. So we've got, in terms of direct competitors, we've got three. We've got one in the US, one in France, and one in the UAE, Dubai. So the one in the US, they're called Jetpack Aviation. They use 6 gas turbine engines as well, but they use it more like a sort of a regular jetpack configuration where you've got a throttle on your arm, and it's all vectored thrust with loads of control systems in place. So you don't really use your body to like make you fly. You just use the computer system to make you fly. They are one of our competitors. Then we've got Frankie Zapata from Zapata Racing in France. He uses a completely different concept. He's got this thing called a flyboard, which is sort of a platform. I don't know if you're familiar with Spider-Man movies. It's similar to like a Green Goblin, where you've got a platform and he's got gas turbine engines inside that platform that make him fly. His concept is, even though it looks cool, it's quite difficult to sort of fly, and he's the only person who's been able to fly that in his whole company, because it takes multiple hours of sort of training and practice to master it, because any small instability can lead to serious consequences basically, and it's not as simple as just our gravity jet suit where you can just fly. Anyone can come in and fly it. And then we've got another one in Dubai. They are sort of the ones that we're trying to like directly compete with. So they're called Jetman, owned by X-Dubai. They have wings and jet engines. So what they can do is they can take off vertically and then transition to horizontal flight and then open a parachute and land back. What they are working on is complete the loop of taking off vertically, flying horizontally, and then landing back again on the power of the jet engines without using a parachute system. And that's what we're trying to reach as well, is have that full Ironman experience, as you would say, of just taking off wherever, whenever you want to vertically, and then just flying horizontally and then landing back again. So those are our 3 competitors that we're sort of competing with at the moment.
Can I just ask if anyone on the webinar is interested in, getting experience with flying the jet suit, how would they go about doing it? Who do they contact?
They just have to email. If they go to our website, www.gravity.co, or follow our Instagram or Twitter handles, they just have to email in to our experience department. It's called Experience, just normal word experience, at gravity.co. If they just email into that email address, we'll take everything from there. And we have a full facility, flight training facility at Goodwood Motor Circuit. And we pretty much train clients on a regular basis. So they can just email us on that email address and we can sort them out.
Brilliant, thank you.
One last one from me is around you mentioned the electric version of the suit that you're working on. Is that likely to, potentially reduce the cost and increase maybe the safety of it to make it closer to something? Could we have Deliveroo turning up with our food on one of these electric suits? Yes,
I mean, the whole reason we're pushing towards electric suits is, first of all, the fuel efficiency. So we do care about the environment, so we don't want to keep burning jet fuel and diesel to do this. But the only way to innovate is start with the tools that we have, which is jet fuel and diesel and jet engines, and then develop further from there to something that's more efficient and more environmentally friendly. So we're working on the electric suit to sort of, first of all, improve the fuel efficiency, second of all, reduce noise, and also help sort of more people to experience the suit, because with the jet engines, it's just sometimes it can be too costly, or sometimes jet engines are not sort of the best mechanical devices to be stuck on to a jet suit, whereas a electric flight version of the suit will be more reliable, will be much more easier to sort of manage as well for anyone who wants to come and learn with us. So that's what our main focus is on with electric jet suit, is environmental efficiency and noise reduction, and giving more people the opportunity to do it. As far as the delivery aspect is concerned, we're mostly sort of, I don't maybe, I'm not too sure. I mean, I'm not too sure if we'll have flying delivery drivers delivering your pizza on a Sunday night or something. But we definitely are looking for the search and rescue opportunities that we have with the suit, and combining the electric version with that, and also the potentially sort of some military aspects to it as well that we can explore. Yeah.
So no orders from Santa Claus at the North Pole yet, then?
Oh yeah, we're developing for him. We're in constant communication with Lapland and Finland, and we're making one for him. Hopefully, it should be ready soon. Secretly, yes. Yeah.
Excellent. I've got some questions related to the engines, Abhishek. So, sort of, how much work did you have to do to the engines to fit them for the jet suit? What have you had to do to sort of make them safe, mitigate any risk of core failure? And do you get weird gyroscopic effects from the engines when they're spooled up?
In terms of gyroscopic effects, not really. Funnily, we don't really get any of that. Mainly because the gas turbines are so small that you don't really get that much torque from it pulling you and giving you torque effects. But in terms of integrating the engine with the suit, it was fairly simple. I mean, the first video that I showed you, our very first trial, was pretty much an aluminium arm tube that we stuck the engine on, and we just used a regular mop bucket with some diesel in it and just wired a fuel line through that mop bucket into our jet engine, and we had an engine running. So in terms of integrating with the jet suit, with the whole suit and flight systems, it wasn't really that difficult. It was fairly simple. So yeah.
Thank you.
Yeah.
So I guess any day now you'll be getting a call from Elon Musk asking if you can scale it up.
Yeah, Richard actually has spoken to both Jeff Bezos and Elon Musk at a party actually, and talked about the suit. So yeah, hopefully in the near future you'll probably see more people using it as a future mobility thing. Yeah, more often. But yeah, let's see what the future holds.
Well, thanks very much to Michael and Samantha and Richard for asking the questions. Really, the main purpose, the main thrust, I might say, in a bad joke, of today's webinar is about inspiring younger people to be interested in science and technology and taking their careers forward. And I think from what you've described of your interest and your journey and the things you've managed to do, from filling mop buckets with diesel to levitating above the ground and making more direct impact on aircraft that perhaps people are already flying in. I think that's a fantastic inspiration for the kinds of careers that that people can pursue. And if you're at all interested in science and technology, we talked about a branch of aerospace today, but Richard mentioned in one of the questions, what about software? That's my particular industry. Richard does things in marine and aerospace and all sorts of stuff, and Samantha does work in the air traffic control. So there are all kinds of different areas of engineering, and almost everything that you touch, and definitely what you're watching us on today, is part of someone's engineering idea and someone who said, what if we did, and then they went and did it. So I think I really hope that that what we've talked about today has inspired you to go and do something for yourself and talk to people around you. You'll find there are a lot more engineers around than you might imagine, and find out about their experiences and what they're interested in, and ask them for the weird stories, like the bucket full of diesel.
Yep, 100%. It's all about putting your mind to something and just going out and doing it, basically, because anything is possible. So
for our 18th annual Christmas lecture, I'd like to thank you on behalf of the audience virtually, Abhishek. That's really good. I can just about hear them in the background clapping now. Yeah, it's very loud.
I can hear them too. It's louder than the jet suit. Yeah. Thank you so much for having me, and thank you so much for everyone to put this whole thing together. And I hope it's been inspiring for some of the viewers who've watched this, and they go on and do something crazy themselves and then make it a reality, I would say.
Yeah, that's great. Thank you.
Thank you so much. Thank you.
So that's more or less coming to the end of today's IET Surrey Christmas lecture, another one for another year. And we hope to be back in roughly the same time next year. Now, who knows whether we'll be hosting it in person at the university or whether we'll be here on Zoom. Whichever it is, I do hope that you can join us then. So a couple of thank yous just before we finish. Thank you very much, of course, to Abhishek for a very enlightening and entertaining talk, and also to Samantha, Michael and Richard for ably wrangling the questions and hopefully putting forward your question. Sorry if we couldn't ask your question directly. With lots of people here tonight, some of the questions get combined, so hopefully we dealt with your topic if we didn't ask the question exactly in the way that you asked for. And finally to Colin and to Tim, who behind the scenes have helped to put this together. And that is pretty much all from us today. Thank you very much for taking part, and we wish you a happy Christmas.
Thank you, everyone. Happy Christmas to all.